Good morning, good afternoon, everyone. Thanks for joining me on two of my favorite topics, actually data infrastructure, meeting ML, meeting GenAI. And so I called this talk Mission Data Possible because we can see how can we make data accessible to GenAI, to our agents, to our LLMs. So a lot what we are seeing right now is, and this is kind of like our mission for this talk, if we choose to accept, is in that upper space, in this agent LLM space, there are like new projects every week. And also just looking here at the agenda for today's summit, we see a lot of talks of basically being up in this layer about how do I deploy LLMs, how do I do MCP, how do I do RAG coming together. So I feel this is a very dynamic space where we basically really have to keep watching the news every day to see like what is the latest project out there. I feel on the other hand, we got enterprise data, and enterprise data is slow on the other hand. So kind of like a question for this talk, our mission is how can we bridge this gap between very slow data down there and kind of this vibrant dynamic space, or maybe to phrase it differently, how can we go beyond prototypes? How can we go to real world business value by giving safe and scalable access to data? So kind of the big picture, what we are often seeing over here, we got enterprise data. We got a data platform down there that might be distributed across like multiple cloud providers, across multiple systems. And it's basically, we have like a lot of pipelines down there. And once we start wanting to consume it, either through RAG or through MCP, making it available up there, we have to go through like this entire pipeline, through this entire mess to get access to our data. So this is kind of like where it falls apart, even though we might be really fast on the top, but then getting access to our production data, making connected, this is usually where we either fail turning a really promising prototype into production or actually failing from the beginning, making this data available. So some of the challenges we have seen along this road is often there's either an internal team or sometimes even like external consultants coming up with this really cool project. They design a Jupyter notebook, they present it to upper management, and upper management saying, yay, it looks cool. But for this notebook, they have used a pre-cleaned version, a pre-cleaned CSV file, kind of like a manually tuned version. And then as soon as we want to actually use the same concepts against production data, we're actually failing. Of course, we would have to get access to databases. We have to talk to the central teams. So basically, the challenge of turning this into something we can use in production. Second challenge, and we already touched upon that a little bit, is kind of like that speed in which things are changing. So there's so many new projects, but basically giving access to the underlying data is still really slow. So how can we make the data available at the speed our autonomous agents require? Of course, this is becoming like a totally different velocity compared to that old world where there would be like an analyst or a data scientist coming in. They can talk to the team, but there's still kind of that human in the loop. Whereas our autonomous agents, as we heard in a lot of other talks already today, and we'll hear a bit later today, we are at a much different velocity, much faster out there. Next challenge. This is actually coming from, we said earlier, it is important to make data available to the LLMs, to our agents. But on the other hand, making too much data available can lead to what is here referred to in this paper as context rot. Basically meaning if we make more data available, which is not specific to the task we want to solve, we're actually decreasing the performance of the overall model. So how can we make only the specific data available, which is actually helping us, or helping the LLM, helping the agent to solve that particular task at hand? And last but not least is kind of the topic of safety. So throughout the last weeks, you probably read about this AI coding tool wiping out a bunch of production database systems and then actually lying about it, why it did that. So while we do all of that, how can we stay safe? So how can we, on the one hand, be fast enabling it, but staying safe on the other hand, that this doesn't happen? If I had to classify these problems into more general categories, I would say the first one we talked about, it is a lot about standardization. How can I standardize access to data? How can I standardize, especially for LLMs and agents, standardize the access to metadata, to the context they require to use that data, and hence enable them to do that at their speed they need. Speed is the other thing. How can I make that data available at agent speed? Next topic would be the specificity. How can I make sure the LLM gets specific data available and doesn't get, or specific context? It's not just the data. It's actually also, for example, as we talked about tools earlier today, there's a number of tools I make available to the LLM, but how can I keep that specific to a particular task without overwhelming the entire LLM underneath, or the LLM backing up that agent? And then last but not least, safety. How can I make that in a safe and scalable fashion? And I think this is especially true if we start talking about our company data, which we all know is probably, I think there was this term, it's like data is a new oil, but it's the core of our business, and it's a core we want to treat very carefully. So basically, how can we stop hanging out there and solve our mission here? Why do I care about this? I'm head of engineering at Nextdata. So at Nextdata, we are building a data platform, a data mesh solution centered around data products. So you might have come across that term. If not, don't worry. I'll give a brief introduction in just a second. But basically, these are problems we're dealing with on a daily basis. And actually, they're very similar problems we have seen in a general data management solution, just at a different scale, right? As mentioned earlier, I think a big shift is that those autonomous agents, they are much faster and much more rapid in their access patterns compared to like a human in the loop, or even like a semi-human writing a script out there, coming up with new query patterns, coming up with new data access patterns. And I think the second aspect, which is slightly different, but not fundamentally from human consumption. It's just a need for like context around the data, right? It's not just about the data itself. It is about the data plus metadata together, which we need to make available out there. In my previous life, I actually worked on a lot of machine learning and data infrastructure across various of companies. So as mentioned, this is why I'm particularly excited to combine this topic of like data infrastructure and AI and machine learning in this talk. Why do we care as a company? As mentioned before, Nextdata OS, it is a data mesh solution, and we'll come a little bit to more details what that's all about. But in a nutshell, what we are trying to do, we are trying to enable data product developers or data producers in the domain teams to really build, share, and manage data much faster than they currently can, where the central infra team often is a bottleneck. We want to enable users to discover, trust, and access data in a scalable fashion. And users in this, for us, can either be human users, data analysts, scientists, applications, dashboards, or it can also be autonomous agents or chatbots accessing data in a scalable fashion. To make that possible, we want to enable the platform engineers, the central data team, to really be able to focus on their job, maintaining self-served infrastructure, and be able to integrate and onboard new technologies, a new database system within hours, and make that available to our creators, but also the consumers on the other hand. Last but not least, not to be forgotten, especially in larger enterprises, are kind of the managers or the governance aspect of all of it. while I want to enable the individual people to create data artifacts, to create data items and share them, I still need a way to enforce central governance if it comes to access to data, if it comes to not leaking PII data, if it comes to where data can be processed. So kind of like merging this local world where everyone is enabled and still enable a central world where everyone where the central team can still manage the central concerns across out there. If we go back a little bit into history, Jean-Marc, founder of our company, kind of also the founder of this concept of data mesh, she raised those questions. What happened if we stopped building data pipelines, orchestrating them, cataloging data, separating batch and stream processing? If I would summarize that, basically, what would happen if we stop building like patch solutions? If I look at the current data ecosystem, we have tools for so many different aspects, for data quality, for catalogs, for pre-processing, and they're basically all disconnected. And a lot of work infrastructure teams or also like data engineers have to do is basically taking all those patch solutions and turn them into a larger connecting system, which often feels very brittle. If there's an API update, this probably will impact other things as well. So kind of the idea to achieve that is to move data from the centralized ownership, where a central infrastructure team is owning all the databases. If someone needs access to something, they're responsible for it, to kind of decentralized domain ownership. So basically, the people who are closest to the business aspect of the data, like producing that data or consuming that data, they should also own that data because they know most about it. So how can we, from an organizational perspective, enable this decentralized domain ownership? Also architecturally, how can we move from like a big monolith to a distributed systems? How can we package data, metadata, code, computational validation into like one unit, and hence actually enable everyone to do that? So how basically Jean-Marc kind of like picked up, how can we make data possible in general? And as you probably saw, this is also seen for this talk, how can we make data possible for GenAI and everything out there? This started in 2020. There's also a really good book around and has grown ever since. I actually feel it from the growing aspect. Everyone has a slightly different interpretation of some of those concepts. So maybe just as kind of like a heads up, what I will share is kind of like our interpretation here at Nextdata for data products and also data mesh in general. What is data mesh? I mentioned that word now so often, but what is actually data mesh? For me, it consists of two different components. First of all, it's the data product itself. So a data product, if you want, you can see it as an equivalent to what Docker containers are to microservices. How can we encapsulate data, metadata into like a single accessible unit? And how can we standardize access to that, right? If I give you a Docker container, you know you can do Docker run, you will get the outcome. And it doesn't really matter whether the app inside is implemented in Rust, Python, or whatever other obscure language you might choose for your application, because it basically comes down to standard interfaces. And similar with data, we have so-called drivers or connectors to the underlying infrastructure. So you can, in your logical representation of the data product, you could, for example, switch from a Snowflake system over to a DuckDB for more local execution out there. And from a consumer perspective, I want to say nothing, but in reality, not much would change, simply because I can go through the interfaces. I still discover it the same way as before. So I basically have a very similar abstraction across the actual physical data plane compared to what Docker containers would be offering for your microservices. I think this is the one part, kind of like Docker equivalent for data. Second part, if you, again, take the microservice equivalent, there was the trend then to an orchestrator on top. I early on worked on Apache Mesos and also early on worked on Kubernetes. So kind of like the data mesh operating system or the data mesh level is kind of that equivalent of that orchestrating layer on top, taking multiple data products, making sure they can connect, enforcing central services such as authentication, authorization, but also provide that central governance layer, kind of like what data products can I launch, how can I enforce central policies are still being enforced. So again, that would kind of be the Kubernetes equivalent to your Docker container, but in the data space out here. So I know this was a very short introduction. If you're interested in more, as mentioned, there's a data mesh book. There are really good blog posts out there, including on our site. So if you're interested, just highly recommend stopping by and learning more about it, or feel free to reach out to me. But for now, let us take a look. How does it actually help us solve problems we are having and we discussed earlier? So if we take that problem of your consultants, they're just handing over this really nice Jupyter notebook, which is promising the world, but has been working with that pre-cleaned CSV file. How would that help here? By having the data products provide a standard interface, we can easily switch from and abstract away from the underlying data. So what we've, for example, seen with a number of our customers or a number of our users is they would start out in the prototype phase with, for example, a local DuckDB instance below serving the data. So instead of putting that in like a cleaned file, it would be served via DuckDB, but it would already follow the same kind of like cleaning process as out there. Because again, that kind of like pre-cleaning, I can formulate that as another data product, and then my data product, my prototype here, would be just a downstream data product consuming from the upstream data product. I think this is part one. And then when I move that over into the production, I can fairly easily switch that from my underlying DuckDB to, for example, a Snowflake instance or a Redshift instance out there for my production, serving my production data. This is basically how we view it, kind of like our data product API. It's API first. So each data product has its own unique URL. So if I want to share a data asset with you, I simply have to give you the URL of the data product. And you can go in and actually, for example, here, query the data product API. So you can build applications around it, accessing just the data product itself. And this goes from anything to get metadata about it. How often has it been accessed? Is it following all the data quality promises this data product is giving, over to if I have the correct permissions to actually get access to the underlying data. How does it look in context, and how does it then maybe also help us solve the problems we've been discussing? So here's the example of a customer feedback data product. So it is aggregating different customer feedback sources. So in this case, we have unstructured data, which is just imagine like in a store, you actually fill out like a feedback form. And at the end of the day, those get scanned and kind of like exposed via our upstream data product here. And the second input data product is a bit more structured. It would be our Amazon reviews, right? They're typically following a pretty nicely structured fields. And our new data product, our customer feedback data product here, is now aggregating this both unstructured data and structured data into like a common representation. We can have different implementations for that. For example, this is actually in our demo environment, this is implemented as a Spark job, but you could also implement that through other transformations or other hosted compute platforms. And as mentioned earlier, this is possible through what we call storage and compute drivers, giving you access to the underlying data plane down here. Very important point on the input side is then the quality checks. So before we would kick off our compute, our Spark job, for example, we would have certain considerations. Do we actually have all the fields we need? Is it does it actually make sense to kick off the job, or is the Spark job just going to feel like a fail like 20 seconds down the line because there's either wrong data or data missing, or even worse, we would get wrong outputs in the end. Second aspect, still on the input side, is we can be very particular and explicit about when we should run this job. So the data product has multiple sensors. So, for example, sensing, oh, my upstream, here's no new data available. Here's new data available. But this is basically then allows me to devise a policy, how often I want to trigger, how often I want to run. So I could, for example, say, I just want to run every night at 12 p.m., no matter like when data is coming in. I might say I want to run whenever I'm getting new data from the PDF site here. Or I could even say, oh, whenever there's a new Amazon review coming in, oh, please update like all my outputs here, which probably is a bit too much. I personally have seen a lot of infrastructures where there are tons of Spark job, Databricks jobs running every hour, but the outputs, they're really just consumed once a week or every few days. So it's good for Databricks, right? Because they get a lot of money for all those compute running out there. But probably for us as a company, having more fine-grained control, when do we need to update? When does it actually make sense from the input to update? Do I need to be close to real time? Or am I actually in a scenario where this is consumed on a much slower basis anyhow? So I have those choices. Enough on the input side. Let's move over to the output side. Equivalent to the input side, we have promises there. So these are promises I'm also seeing as a downstream consumer of this, and I can go in and basically get make sure that certain conditions are met, and otherwise I'm not going to access this data. And this is actually ensured before we make data accessible to downstream consumers. So in kind of like a promotion process, which you can compare to like asset transactions in databases, right? Either I'm making the entire output available, but only after certain checks have based, or all my downstream consumers, they're just going to see the old version of that data. Furthermore, on the output side, we can have data available in different physical representations. So the same semantic data model might be available in a kind of like more document format for kind of like model fine-tuning and training. It might be available in a relational form in a SQL database for my data scientists who want to connect via a Jupyter Notebook or via a dashboard. And it might be available as embeddings to any RAG consumer down the line, who wants to consume it in an embedded form. And all of those, they are different physical representations of the same data. What we earlier this year added is also an MCP output. I don't want to be like too particular of calling that just MCP, because I feel it's more. It's kind of like an API output, because this way, I as a data product developer, I can tell LLMs or even human consumers, these are the questions my data product can answer, right? By either providing MCP resources or by providing MCP tools. But the person who has most knowledge about what are good questions is not like some central team building one MCP server in front of my entire infrastructure, but basically the data product developer who's in the domain of that data, and they are also best and able to say like, these are the resources, these are the tools who should be available. In turn, these tools can be discovered through mesh metadata. So if I'm building a tool, I can just connect to the mesh metadata, kind of like as an MCP gateway, and that will expose the different tools down here. And we'll see that in just one more second. I'm seeing I got like 5 minutes, so I'll speed up a bit, very fitting to the topic here. Speed was kind of the challenge of how can we bridge this different cycle times, right? Our app cycle times, that's going to be like in the seconds. We might deploy a new app. They might want to read data. We might want to give them access to new data. But kind of like down here in our data infrastructure plane, we are at a way different velocity out there. This, again, is where we want to, or where data mesh in general and Nextdata in particular is tries to enable building those data products very quickly. So we have a LLM-based tool called, or a co-pilot, basically, Nextdata, which allows us to build new data products in minutes. And then, due to the standardization we just discussed, they're automatically available, given the right permissions, of course, to downstream consumers, right? So basically, bridge this gap in between very slow moving down here and fast moving up here by allowing people and data product developers to quickly iterate on and build data products. Specificity. So we already mentioned there's this concept of context rod, and there's here a really good blog post by LangChain talking about agent performance if we make more context available. And that can either mean I'm making more data available, but it can also mean in the MCP context, I'm making more resources available or more tools available. So more tools there are available, the harder it will be for the LLM, for the agent to choose the tools which are actually specific and best for this task to use. And this is why here in this upper graph, we actually see the performance decrease for some models more drastically than others if we make more tools and domains, in this case, representing data available. So they quickly become overloaded. So our challenge is, how do we make specific data available? And again, just tying that back to the domain model we've been talking about, and in a theme I would call domain-centric GenAI, and that would be making task-specific data and tools available. So this is true for both data. So basically, if we are in a RAG-like scenario, only make that particular data available, which is relevant. If we are talking tools and resources, only make those tools, MCP tools and resources, or if there's a new protocol down the road, similar concept, but basically just makes the tools available for it, which are relevant to it. And this can actually be even extended to domain-specific LLMs. It can either be different base models for different tasks. So a finance domain probably is going to use different LLMs in the marketing or the engineering domain. And it can also then be specifically fine-tuned models for different domains. So as mentioned, if I'm in marketing, maybe have a marketing fine-tuned version of my base LLM. If I'm in the finance domain, have a finance fine-tuned model of that. How does it look like kind of in the agent lifecycle based around data products? And this is what I think nowadays is often referred to as progressive tool discovery. So kind of the agent lifecycle, first step is it's getting a prompt or task, and it discovers its intent. And with that intent, it can actually leverage tools. And at the beginning, the only tool available to that agent, to that LLM, is going to be discover other tools. But if it's giving us the context it needs for its tools, then in the next step, we can actually get the tools which are specific to that task at hand. So for example, here in step one, the LLM is going to call this tool, and then the MCP protocol supports this progressive making new tools available. We would see our second tool, that would be here, get customer feedback for a particular channel. So that actually then allows the LLM to choose the particular data products or tools for that particular task. The standard protocols, the standardization of the data product allows access to the underlying data or tools, and then we can actually do what we do best as agent or LLM, take our decisions, and we start our cycle all over with potentially a new set of tools being available for that. But by this way, by using progressive tool discovery, we don't make like too much data available. We only make specific data and tools available. The other quick note on that, we can actually also make specific context available here. So the description, most examples are actually very specific or very static, right? Like if I have a normal MCP tool or resource, I'm going to have a static string. With this progressive tool discovery, you can actually make that description, the metadata, specific to that context, to the task at hand as well, enabling the LLM to really pick the right tool. Last but not least, safety. We talked about consumption, right? We really want to enable data product developers to chunk out and be quick on those. But on the other hand, there's a CISO or some manager saying like, oh, no PII can be exposed. So how can we bridge that gap? And this is, again, when the central policy component, for example, is coming in, right? We talked about those promises out here, and those promises, those data contracts, they can come from a central contract repository. And then there can be a policy which says like, oh, any data product running, it must fulfill the PII promise that we are not leaking PII data. And again, this can be specific to different domains out there. So kind of just to wrap that up, kind of the pillars of that scalable road from prototype to production, they are standardization, where data products serve as a standard interface, speed, data really being served at the autonomous agent speed, and data products being developed quickly, specificity of data for the task at hand, and then also safety with policy enforcement across data products and particular domains. With that, I think there's a QA tab. I'm happy to stick around for a bit longer. Otherwise, feel free to drop by our website for kind of like bridging that gap for data gap for AI. So thank you so much for listening. I know I'm over for 2 minutes, but happy to stick around for a bit longer for questions. Otherwise, thank you very much for listening.